I'm going to be talking to you about move fast without breaking things, how we deploy the largest Python site in the world, and if you didn't figure it out, it's Instagram for the color scheme. Okay, cool. Okay, so who am I? I'm Alvaro Leiva. That's my Twitter, that's my Instagram. If you want to follow me, go ahead. I'm an Instagram production engineer. My team is called D&D, which doesn't mean Dungeons and Dragons. It means development and deployment. And what my team does, it's something that at least I find it that is kind of cool. We make our own case to take code from the fingers of developers, that's how we call it, to 1 billion users in our continuous pipeline. So basically, like if you're an Instagram developer and you want to develop on the backend, we make sure that everything that works on your dev server, so you can code, so you can run tests, then you submit your code. You will normally call it pull request. I will call it diff because that's how we call it inside of Instagram. So if you hear the word diff a lot, it actually means pull request. Then how you land your code into master, because we develop a master, and then how we deploy it to our billion users. One thing to say is that this is going to be my first time, actually my second time I give this talk earlier, about doing soft skills speaking. In general, I usually known to do a little bit more like technical stuff. Like I put one of my talks there, it's called like how do you do systemd development with Python. I'm the author of systemd. So yeah, let's see how it goes. This is going to be the first time that I actually talk about like the philosophy of how do you code and why you should move fast and how do you take certain precautions not to break your site, more than actually like let's start coding. Okay, cool. So why am I talking? A year ago, my manager at the time gave a talk at PyCon about how we moved from being like Instagram and having 2 developers, Mike and Kevin, to be like this huge company that we're now. And he went and spoke to all of the stages of our development. When we start like deploying SSH into a machine and just copying the code to whatever we have now, that is the thing that I'm going to talk. And the talk was actually like pretty cool, and I would recommend everybody like to go and check it out, because no matter what size you are, we will probably at one point similar to you. So it's kind of cool. Like you can see like, oh, what was Instagram doing when they were like having 100 users, right? Or when people were just sharing pictures of bars, which is a fun story about how Instagram started. So yeah, so go check it out. But the reason why I'm talking here is because a lot of people were interested of what exactly are we doing now, instead of like our whole history, like what things do we do now. So that's basically what I'm doing. So this is called move fast without breaking things. Let's start with the first part. How do you move fast? So let's start with a small poll, raise of hands, because this is how you should start all talks. Raise your hand if you manage a service that gets deployed at least once every 2 weeks. Okay. Now, keep your hands up. Come on. Okay, this is going to be fun. Okay, so anybody who hasn't raised their hand, I'm assuming that you don't manage services. Okay, so keep your hand raised if you deploy your service once a week. At least once a week, I mean. Okay, cool. Never. Okay, keep your hands up. Keep if you deploy it once a day. Okay. Twice a day. 5 times a day. Okay. Okay, there's, okay, here's 10 times a day. Okay, 50 times a day. Okay, cool. Okay, awesome. Yeah. Okay, so if I were to say 51, I would also have to like take my hand down. Sorry for the noise. Okay, so at Instagram, we deploy around between 40 and 50 times a day, which we basically call we deploy every 7 minutes. And this is what we call by move fast, like move frequently fast. Okay, so the way that let's go directly. So first, before talking like why would you go into all this trouble of deploying very fast besides giving very good talks? So let's talk why. So let's go through some horror stories that probably we will all be hearing. We are all familiar with this. So let's start with the first one. So stop me if you heard this one before. You put once at the end of your sprint for whatever definition of sprint you have, like once every 2 weeks, once every month. I don't care. It's sprint, the most ethereal thing that exists. So you deploy, and usually if you deploy once every sprint, the sprint ends on a Friday, so you deploy on a Friday. So Not very good, because then you have Saturday and Sunday, and then on Monday, the next day, people realize that one of the features that you deploy is broken. Okay, so crap. But the problem is that since you have your code in production for a lot of time, you can roll back. Database incompatibilities, a feature, like you didn't just deploy one feature, you deploy like 10 features. So the fact that one is broken doesn't necessarily mean that you can do it. So then you have to push a hotfix, which is not fun. Like hotfix should be like the most banned word. So look at the PE. It's a little bit broken. So let's go to another horror story. Stop me if you heard this one before. You push at the end of your sprint again. Your push is good, right? So everything went well, perfect. But mid-sprint, somebody needs to deploy something ASAP, right? So here's the problem. Since you deploy at the end of the sprint, there's no guarantee that master or whatever the thing that you want to deploy is healthy at any given moment in time, except at the end of the sprint. So if you need to deploy something in the middle, it means that probably that thing has also other things that are broken. So now you either have to cherry pick, horrible idea, but sometimes it's the thing that you have to do, or you have to deploy a bunch of not good tested code that probably are behind gates, probably not, feature flags, yeah. So yeah, the pig is a little bit broken. So stop me again if you heard this one before. You push to prod only when, oh, actually this one happened to me on a previous show. You push to prod only when you need, right? Because not all services need to be deployed in a sprint. Like you do a CLI, that's perfect. You realize that the code that you deploy is broken. So you are going to go and try to find the author of the original code to find why it's broken. The author left the company or the team. Yeah, so now you need to deploy a hotfix on a code that you don't really understand, but now, trust me, you own it. Yeah. Okay, and I think this is the last one. I don't want to bore you with all these stories, even though they're fun because they reflect our own guilt on our system. You push to prod only when, actually I have another one. So you push to prod only when you need. Oh yeah, this is actually quite cool. You work hard to get a feature done, right? So you work the week, whatever, to get a feature that a client requested. You deploy it. Perfect, everything goes well, and the client sees it and goes like, actually that's not what I want. And it's like, I spent a week. If I would have shown you this at the second day, you would probably have told me this, and I would only waste like 1 day. So yeah. Okay, so now instead of like going to story, let's just go to tweets. So you push to prod only when you need it, and as soon as you deploy, a new features come in and it needs to go out. So it's like you do all this work to deploy, and then, damn it, I need to deploy another thing. You find out that you missed something when you deploy. You deploy all the things, and then you forget, crap, I forgot to turn on the feature flag for this feature. I need to deploy again. Your company changed logo in the middle of the sprint, and you need to update. Your company got acquired in the middle of the sprint, and you need to change all the pages. Something that does happen, yeah. Or this actually was suggested to me, and it is very funny, but like you deploy once every 2 weeks, but the guy who was supposed to deploy the last time forgot to deploy, so now you end up deploying 4 weeks of code. Not fun. Okay, cool. So yeah, so at Instagram, we, at the beginning, Mike and Kevin, when they started and when we joined the company, we kind of have gone through all this experience, right? So we tried to make something that was better, but also understand that we were very small at the time, so we could not do whatever we want. Now we can do. So what do we have in Instagram? So Instagram, first of all, we deploy directly from master. We don't have feature flags, we don't have feature branches or release branches. Everything that you land on master. So imagine this is master, you have commit 1, 2, and 3. Commit 3, it's the thing that is on production. It's the thing that you are looking at your screen, right? Well, you're not looking because it's the backend, but it's the thing that you're looking is talking to. So then comes a developer and goes and commit code. He commits directly into master. Then another developer, a drunk version of me, goes and commit another code. And then, of course, it's commit 5. So what we do is the following thing. We move master to commit 4. Like of course, we make it into package, we build all the Python things that we need, we put it into production, and then we let it sit there enough time so we get signal that this thing is healthy, for whatever definition of healthy you have. And then we move to the next one. It's actually bad, that should be red, but let's imagine that commit 5, we deploy commit 5 and then the site goes down. Like that's the most horrible thing, but it can be like anything, like a database gets overloaded, there's an alarm, like likes goes down or logins go down, people get logged out, like anything. So about it like this. Commit 4 was healthy. We moved to commit 5. Commit 5, it's broken. Probably the things that we deploy, the thing that we broke. So what we do is that we roll back to commit 4 and the site is healthy. The cool advantage of this is that since the developer was around when, like, the developer landed code, we deployed, he probably is around when we deploy it. So we can go to him and ask him, hey, like, apparently this code broke production. Can you help us understand what happened here? And then he goes and look and say, like, I don't know, like, non-type has no attribute ID, right? So anyone who is a Python developer knows that that's the most horrible exception that you will get. So the developer is the best person to say, oh, crap, I forgot to put a tag catch or to verify if it's not null. So he can make this change, or somebody else can revert it. Our uncle are very good at understanding Python. So then we move the site to commit 6. And then the machine keeps rolling. So with having this, like, moving very fast, by moving very fast we mean like trying to deploy as little commit as possible, we are able kind of to identify what changes produce what breakages, or what changes produce what improvement. This also goes the other way around. We call this like don't break things, but also if you have GCPU and then you deploy a code and the GCPU goes down, as a good thing, I mean like a performance win, like you know, okay, so this diff is the one that produced the performance win. So you can actually like attribute like good things and bad things to diff. Okay, cool. So why? And this is the soft part. So what I've been saying so far, like when we isolate changes, this allows us to also isolate source of breakages, right? So again, if the site is working, you move to a new commit, the site is broken, you move back, the site is healthy, it's broken, then you kind of know, like, then you kind of see a pattern. So this actually like helps the on-call a lot. You can also like mix this with like deployment patterns, right? So if you deploy in one region first and then on another region, and then the region that you deploy first goes down, and then the region that you deploy after goes down, and this follows the scheme of how you deploy, you can also kind of isolate certain type of changes. This will not be possible if you landed like 2 weeks of code at a time. So the other thing, and for me it's the most valuable, or not everything is valuable, but this is actually very valuable. It's that since we landed code and we will send it into production very soon as you landed, we try to have an SLA of an hour, a stop SLA. We sometimes break it, we sometimes are very good at it. Developers are usually around, and we expect developers to be around when they land code. We don't want them to land code and then get on a plane. The idea of that is that they are the best person to understand what their code does. It's very important because now developers are in control of their code, right? So they know that, oh, I can land something and then I can check in production, like, is it doing the things that I want? And then sometimes the developers themselves, they say, oh, it actually didn't work, so they revert it instead of like having to do, instead of having to wait like cycles of 2 weeks to get this done. And another unintended thing when we start trying this is that diff is starting to get smaller. Since we deploy every single commit has to be healthy. So the way that you achieve that is that you, instead of like, you can make like a big diff or a big pull request with all the changes. Or you can make a small one and then stack them and then land them at your own pace. And that actually produces a lot of things, because the first thing that it produces, it helps code reviews. If the code is smaller, it's easier to understand. Other people besides people on your team can review it. It's kind of easy to understand. Also, if you land like a big diff, and then I need to revert that, I will revert the entire diff. So if the diff does 10 things, and I only want to revert one, I have to revert the 10 things. While if you run smaller diff, you also have this chance. Also, if you're working on a long diff and there's many developers, trust me, you will get rebase conflict. All right. So another thing is that since we deploy very fast, developers don't really care about if we revert their diff. Actually, they come to us and say like, oh, I'm sorry for breaking the site. It's like, oh, okay, you're welcome. And the reason why they don't care about if we revert the changes is that because they just go and fix it and land it again, and then goes into production. There's no churn. The other thing that this actually makes is that reverting a change is also no longer a hotfix. Reverting a change is just like, I don't know if anybody has like a reverted diff, but you basically create the opposite diff, right? So if you add a line, the revert is literally removing the line. It's not removing the commit, it's adding a new commit at the end that is the opposite. So that's just another commit. That just goes to our pipeline. If we test it, if we canary, if we do whatever, we do the same thing with a revert. So there's no concept of hotfix anymore. And I was getting ahead. That's basically what it means. Fixing forward is painless. You either revert or you do, or you change the change. Okay, cool. So moving a little bit faster on this. So to be able to deploy code, we need to be able to deploy code that is not broken. The most important thing then is that you can't land code that is broken. So we need to stop bad code before landing, because since you're going to deploy into master, land into master, and then we're going to deploy it in less than an hour, we have to make sure that the code is healthy. So how do we do this? So at diff or pull request time, we run tests. On Instagram, I think we have like I can't remember the number, but it's like 40,000 tests. And all of them, we run them at diff time. So you will get signal of like, is my change breaking? Like, I'm making a change on how you view your post. Is this going to break logging, right? So this is like diff. And then you submit diff, again, pull request. You submit your pull request, your peers review it. You have machines reviewing your code, like running typing and security checks and everything. And then you go, everybody says like, my diff is ready to land. You try to land. So we run tests again, because why not? And then we run a thing that we call Canary. Canary, it's quite a cool idea, and you can make it if your system is strong enough to support this. Basically, we take your code, and we put it into a small amount of machine, like 10 or 20. And then we take whatever is in production, and we put it in the same amount of machine, which are similarly like geolocation and similar hardware, so we will get. And then we compare metrics among them. And then we will see if your diff like making production like catastrophically worse. It's trying to find stuff like if somebody uses your version of the code, they are going to get like a random text, or they are going to get like, they're all going to get logged out of the application. So yeah, so we run Canary and we run tests, and this is very small. And then we allow you to land. So then we deploy it. When we're deploying code, this goes into our post-commit pipeline. We run tests again, we run Canary again, and we do this because merge conflict or land races are very fast, and it can happen. Then we send your code to phase 1. We call it C1, but it's about like 2% of the fleet. So we put it into like 2% of the fleet, and we let it sit, so we will get enough signal to say, okay, your code didn't break test, your code didn't break Canary, didn't break 2019, and your code didn't break 2% of the fleet. Okay, we are good to go. And then we send it to our billion users, or what we call the entire fleet. And that's how we deploy. So this is how we guarantee that we don't break stuff, except that we sometimes do, because, yeah. So this is the second part. How do we deal with breaking things? Raise your hand to do it again. Just a question, you don't need to keep it raised. If any of you had like a SEV process that you manage in your company? No? Does anybody here knows what a SEV is, or I'm going to choose? You, sir. Okay, so SEV means either like side event or severity or anything. It's what ITIL would call like incident management. But it's basically a SEV. It's something that at Facebook we use a lot. I think the terms came from Amazon. I mean, it came from Amazon, but I don't know like what the reason they do it. Okay, so SEV means when there's something that it's worth taking note, like the site is somehow broken, and we can go into definitions a little bit later, but you call this a SEV, and then the SEV goes next to a SEV review process, where you annotate what happened, what could have existed, what would like to have existed so that this thing could have been either remediated sooner or didn't exist at all. And inside of Instagram and Facebook, we encourage people to open SEVs at all. We have like a saying, and it's like if you're doubting to open a SEV or not open a SEV, just open a SEV, right? And then we're going to go through severities of SEVs. But again, it's an ethereal concept. It's meaning like something's broken. I need to annotate it so I can follow you up and escalate escalate the importance of it. So these are not the definitions that we use at Instagram. These are not the definitions that you should use if you're planning to implement something like this. These are just the definition that PagerDuty put on their webpage, and I thought that were good enough as a starting point. So SEP has levels. SEP 1 is the most bad one, and it's basically a critical issue that warrants public notification or liaison with executive teams. Your site is down. Like literally nobody can log in. Or like something that is like, if you work in our company, it's probably something that will need PR support or legal support. If you work like on a command line tool, it's something that is actually like deleting records on your database. That kind of things, right? So that's a step 1, like very critical. Then there's a step 2, which is kind of like a little step down. It's maybe the site is not down, but maybe there are features that it cannot be used, or there is a group of people who cannot log in into your application because like a random firewall in some random countries is blocking you, stuff like that. So basically it's hurting the ability of your users to use your product. Again, feature, these are definitions made by PagerDuty. You work on this. And then the step 3, which is the one that you should try to mostly common open, is something is affecting like your site. Like you may be overlogging, so you're overloading your logger service, or you are, or something that requires immediate action. The good thing is that, at least at Facebook and Instagram, the culture of SEPs is that if I go to another team and ask them, hey, can you help me do this? They will probably say, oh no, I'm kind of busy doing my thing. Oh, I have a SEP, and everybody just stop and then says like, okay, cool. We have a SEP, let's go fix this out. And then you go to this SEP review process where everybody like gets together and talk about the SEP. So having a good culture of this is actually very good. So this is a picture that I take from my desk. Like that's not my desk, of course, it's the opposite. It basically something that it means accountable does not mean guilty. And this is very important. It's the same thing with TIFF. Like again, with sale, you landed code, that code was broken, we ask you, how can we fix it? We are giving you the accountability. We're not saying like you broke the site. We're saying like, can you help us unbreak the site? When we joined Facebook, they give us the stickers. I don't know if they still do this, but and this is very like close to mine because it means like this is now your company. Means that we are very responsible of the things that happen. That means that we cannot go and blame somebody else when something's broken. Like we will go and fix it. This means that if I see a diff that is going to break the site, I have the power to go and unland it. Doesn't matter if it's not my team or anything. If I think a diff is already landed and it's going to go and break the site when it gets deployed, every engineer at Instagram has the ability to go and take the log and stop that thing for doing. And people do this because they feel better. So this is kind of like having this system where you tell people like, hey, we want to know, but we're not going to blame you. It's not about that. It's about like trying to find out how we can stop this again. It's very good because people feel responsible for their things. And then people start like acting less scared of saying, oh, I think this is the thing that broke the site and I did it. And I keep saying the word break the site. Remember that breaking the site means you're just logging garbage into a log, right? So it's just that. Okay, cool. This is also very important. Empower engineers to break things and also empower engineers to fix things. So don't go and scream to an engineer and tell him, hey, you're making my life horrible because now your code is broken, right? So no, you tell them that you have an issue, ask them to help them, but also very important, and we're going to go in a few slides about this, empower the engineer to actually come with a solution that it's going to stop this from happening again. So I'm landing a diff that is going to log into, excessive log into a login device. Okay, so maybe instead of like beside canarying for like logins, we should also canary about like login to devices. And then you add that, and then you improve your system. And then the engineer feels, oh, I actually like help myself. So that's very important. Also makes them own things. This is the most important thing that, and I know that I have said the most important thing many times, but a lot of things combined can take down the site. And again, if you are going to live with one thing from this talk, is the following thing. Root causes don't exist. And this is something that I have believed firmly for the last 5 years. And it's basically, when your system is very complex, and almost all systems are complex today. Like, there's never one thing that takes on the side. There are contributing factors and triggering factors. But you cannot say like, oh, because the person who coded this 2 years ago didn't like foreseen this, this is the thing that broke the site. No, that's not the way that it is. You cannot prevent everything. One thing that happens a lot in Instagram, I'm pretty sure you are going to identify with this, is that a lot of the issues that we see are not somebody causing a bug, it's somebody triggering another person's bug. Because the other person didn't foresee that, oh, apparently now we don't have 100 users, we have 1 billion users, so we should scale this, right? So it's usually triggering bugs instead of like causing them. And this is the last slide. And then we can open the floor for questions if there are. Okay, so basically, once you land your code, we lost the race. So we have to stop you before landing the code. Code review with human is not necessarily the best thing. So we have a saying, and it's like, if you land code, then and that code breaks production, it's our fault because we allowed you to land that code. So this is what it says. Like, if breaking the site means that the tool fails you. Right? Of course, there are things that you will not put 1 divided by 0 in your code, but if we can't catch that part, then it's also like our fault. So every time that something breaks, take that opportunity to make your tooling better. I'm not gonna this is not gonna be news to you because like everybody talks about this, but try always to automate as much as you can of your process, and try always to find like robots to do stuff. Hello? Is this a Seb? Okay. Okay, cool. And with that fun thing, we're done. Thank you very much, guys.